We take small angle approximation for sine and tangent functions whose value is equal to the small angle itself. So we have with us the sine graph and the tan graph. So we will understand why we take the small angle approximation for sine and tan functions as a small angle itself. So if we closely observe the sine graph, what is a small angle? This is 0, this is 0. So we can approximately take a very small angle, that is this one or this one, very small, or this one. Now if we closely observe the sine graph, we get to see that there is a structure in the graph like this, which we can say that it is kind of y is equal to x graph. So we get to see this blue colored graph as y is equal to x. So for small angle, if we draw the coordinates here, so it will kind of become like this and like this. So for small angle, you can see that we are getting a graph close to y is equal to x for sine graph. So we can say that for very small angles, the function can be written as sine theta, where theta is very near to 0, is equal to theta, and by this way we take the small angle approximation for sine functions. Now let's come to the tangent graph. Here also we can see that the line is crossing through this point. So let us consider this as a small angle, theta suppose, and on this x, on the negative axis too. Here also we can see some kind of graph which is resembling the y is equal to x graph, if you can see. So for very small angle of the tangent, we can also take the small angle itself as a small angle approximation for tangent functions. If we draw the coordinates here, so for this one, for this one, so we are getting a graph which is resembling the y is equal to x. So for the small angle approximation for tan functions, we can write tan theta, where theta is nearly equal to 0, can be equal to tan theta, because we are getting a graph which is similar to y is equal to x near the origin. Now we can also see that we are also getting the same graph at these points, that is minus pi. Somewhat like here, and also like here. So why can't we take small angle approximation here? Let me tell that here if you take small angle approximation, this is minus pi. So it is a number which is right to minus, it is an angle which is right to minus pi. So we are getting the value according to graph, the value of y axis according to the graph as here, and it is quite resembling this point. So the angle we are taking is as long as this in the x-axis, and the angle we are getting in y-axis is only this much. So here the tan theta is not equal to theta. Okay, so we got that for sine and tangent function, the small angle approximation, if we take, so the values will be equal to the small angle itself. But now let's come to the cosine graph, where we cannot do the small angle approximation for cos theta is equal to theta. we can't get any such graphs like if I take very small angles which is close to 0, so in this region it will fall. So maybe this is theta and this is theta. Clearly you can see this length is much smaller than this length. We can take the value of small angle approximations for cosine function as maybe equal to 1, because the small angle approximation for cosine will here be 1 plus no 1 minus, and here also we can take the value to be 1 minus. So we can see that we are not getting cos theta for small angles as equal to theta. So this is, thank you.